relations. We can have categorical things, not just numeric. We can say, hey, Colorado has a relationship with Denver, like California has a relationship with Sacramento. Hey, we might be talking about capitals, states and their capitals. That would be a relation. We could say somebody works 8 hours, they get paid $96. Now with relations, it can be something kind of crazy too. We can say, okay, let's hook Colorado up with one of its other towns. Let's talk about Lyman. Well, no longer is this a relationship between the state and its capital, and this is a relation, but if we start talking about functions, functions are a specific type of a relation. Whatever the input is, you can only have one thing being associated with it. Because we added another ordered pair where Colorado was also getting hooked up with Lyman, this relation, these three ordered pairs right here, would not constitute a function. For us to have a function, we'd have to eliminate this ordered pair because it sends Colorado to a second outcome. So to have a function, every input can only have one output in the ordered pairs. Right now, if we had this over here, we could say, hey, somebody works 8 hours, they get paid $96. Somebody works 9 hours, they get paid $108. This would be a function. It's definitely a relation, but it would also be a function because 8 hours is only getting used once, 9 hours is getting used once. But if some Yahoo came in and said, okay, if you work 8 hours, I'm going to only pay you $72. Now that relation is not a function. Because there's some confusion. Does 8 hours get hooked up with $96, or you can only pay me $72 when I work 8 hours? So this set of three ordered pairs would be a relation, but it would not be a function. The only way to make it a function is to take out one of the ordered pairs that has the 8 hours in it. Now this relation is also a function, because this input only has one output, this input only has one output. If we see a table of values, maybe somebody says, hey, you work for me, you take your chances. You work 2 hours, I'm going to pay you $12. You work 3 hours, I'll give you $22. If you work 5 hours, I don't pay you anything. So it's like, okay, weird. Is this a relation? Yep. Is it a function? Yes, because the inputs, each input is only associated with one output. Now, if somebody comes in and says, wait a minute, I'm going to add another ordered pair. If you work 5 hours, I might pay you $30. Who knows? Now, this is a relation, because a relation has no real restrictions other than it's got a bunch of ordered pairs, but the 5 got used twice, so it would no longer be a function. If we eliminate this thing back here, now this does describe a function, and a function merely has every input only associated with one output. If it comes to a quadratic function like this right here, if we start making a table of values for this, if you put in a 2 and you square it, you'll get back a 4. If you put in a -2 and you square it, you get back a 4. This is not a problem. You can use the same output more than once. Every input can only get used once. So this parabola would be a function because no matter where you go on the x-axis, every x is only getting hooked up with one particular y. If x is 3, y is going to be 9. That's the ordered pair 3, 9. You're not going to find any two ordered pairs on this graph that have the same x values. So this is a function. Now, if you contrasted that with x equals y squared, now that puppy would look like this. That would be a parabola sitting on its side. And now we have a problem. This would not be a function, because if you thought about like this guy right here, this might be the number x equals 9. And when x is 9, y could be 3. So we could have, the ordered pair where x was 9 and y was 3, because if you take 3 and square it, you get 9. But we'd also have a point down here where when x was 9, y could have been -3, because if you put a -3 in here and square it, you get a +9. There's two different x values, two different inputs that are going to different outputs. So this is not a function. And we learned to do the vertical line test. You should be able to put a vertical line anywhere on a graph and never hit more than one point. If you hit two or more points, that implies that one x value, like in this case 9, is going to two different y variables. So this is the vertical line test to see whether or not a graph or an equation is a function. This fails the vertical line test. There's more, one x is getting hooked up with more than one output. But over here, no matter where you put a vertical line, you will never hit 2 points on the graph simultaneously. This passes the vertical line test, so it is a function. So basically the definition for a function is that it is a relation in which every element of the domain is used exactly once. Wait a minute, what are we talking about when we're talking domain? If you remember from earlier in the class, all of the inputs, all of the x values, all the inputs are part of the domain. So all the x values we can use here would be the 2, the 3, the 4, and the 5. So that would be the domain. The domain we'd show on our work, the domain would be the set containing 2, 3, 4, and 5. And then we say, well, okay, what would be the range? The range would be all of the y values, the 12, the 22, the 17, and the 0. So we would say, oh, okay, the range, which are the y values, would be, and again, we could put these in ascending order, so we could do the 12 and the 17 and the 22. So this set would contain all the output values, so that's the range. Now what I told you guys earlier in the year, look at me. I should say input, and this would be output, and then domain, and this would be range. So in the alphabet, X comes before Y, I comes before O, and D comes before R. So the X is the input and the domain, and the Y is the range and the output. So just think alphabetically. Now, when it comes to a continuous function like this, there's infinitely many X values and infinitely many Y values. In this one, the domain, you can put in any X you want. You could put in 1 billion, and that would be fine. You could put in -5 trillion. That would be okay. So this parabola keeps getting wider and wider. There's no restriction on the X. But do you see that you'll never get a Y value that's negative? No matter what you put in for X, even if you try to put in a -100, when you square it, your Y value is still going to be becoming a positive number. You can't get any Y values that will be negative. This graph will not go below the x-axis. So for that reason, we say that the range is going to be all Y values that are greater than or equal to 0. So all the Y values will be at least 0, so that's the range. The domain would be all reals. It would be all real numbers because you don't care what you put in for X, there's no restriction. So again, a function is a relation in which every element of the domain is used exactly once. Every input can only be used once, or in most cases every X value can only be used once. So one question would be, all right, what about this? What about the line y equals 3? Is it a function? Well, if you think about it, if you tried to make a table of values, do you agree if you put 0 in for X, Y is going to be 3? If you put -1 in for X, Y is going to be 3. If you put 100 in for X, Y is going to be 3, because there's like no place to put the X. But you remember what these lines look like. That line, Y equals 3, that's a horizontal line where every point on this line has a Y coordinate that's equal to 3. Well, that is a function because it passes the vertical line test. So it passes the vertical line test. I hope I didn't call it a horizontal line test earlier in the video. I almost think like maybe I did. It's the vertical line test. So as long as you can pass a vertical line anywhere through here and you only have one point on the graph, you know it's a function. And that's because no X value is going to get used more than once. The Y value is, it gets used repeatedly, but that's okay. This guy only gets used once. one last thing then, is the line x equals -8, is that a function? Well, if we look at that, then -8 is down here. Okay, so this would be a vertical line that goes like this. Do you agree this is not a function? Because just like any gigolo, it gets hooked up with any number of different y values. So it's a playa. Okay, but anyways, it gets hooked up with any y values. So the 8 keeps getting used over and over again. So we can have x be -8 and y could be 2, x could be -8 and y could be 4, -8 and 0. So the x's are getting used over and over again, so not a function. It fails the vertical line test miserably. Anyways, functions and relations, that's what's going on there.